So in this video, I will show you how to integrate the product of the differential function that can be solved using the power formula of integration. So you can only say that this is the product of the differential function if we have, for example, the derivatives of a function 1 is equal to a that derives with respect to x, and the function to derivatives of a function 2 which is equal to b that also derives with respect to x, and these two functions are multiplied together, and this is now represent as the product of differential function. So in this kind of function, the formula that can we use here to integrate is the power formula of integration. But not all function like this we can integrate using the power formula of integration. So that is why in integrating a function, what you need first to identify if what formula you should use in order to make it easy to integrate. So for example, if we are going to integrate this function of x is equal to the integral of a times b dx, where a and b are both functions, so we can only use the power formula of integration to this kind of function if the derivatives of a second function, for instance b, which is b prime, is equal to a, or vice versa. The derivatives of a function 1 which is a prime is equal also to b. So in these aspects we can use the power formula of integration, which is, as we know, the power formula of integration is simply as integral of a function raised to the power of n is equal to u raised to n plus 1 over n plus 1 plus an arbitrary constant. So for example, if we are going to integrate a product of a differential function, for example x squared times x cubed plus 3 raised to 5 dx. So as you can see here, this is our second function, this is our first function. So if we're going to differentiate the second function, it would be equal to the first function. So what we use here to integrate is by u and du substitution and representation. So therefore, if let's say it is our b and it is a, now if b prime is equal to a, therefore we're gonna represent our b as our u. And we're gonna represent our u as a b. And if our a prime is equal to b, therefore our u here is our a. So let's try this problem. So because our b prime, our second derivatives of second function is equal to the first function, what is our u here is the second function. So we have our u here, we let u is equal to b, which is x cubed plus 3. and our du here is equal to 3x squared dx. So this is our b prime, and which is equal to our a. So therefore, as we represent this function as our u and du representation, we're gonna make it to substitute from the original function. So we have integral of x raised to 2. This thing is what is represent this as our u. So we have u raised to 5, and our dx here, if we derive this one, our dx here is equal to du over 3x squared. So we substitute our du here, our dx value. So we have du over 3x squared. And as you can see here, we can now simply cancel our first function from the derivatives of the second function. So what remaining here is we have a constant which is 1/3, and we can put it outside the integral sign. So we have 1/3 and the integral of u raised to 5 du. So in this way, we can easily use the power formula of integration. So we have now, it would be equal to 1 over 3 u raised to 5 plus 1 over 5 plus 1, where our n is equal to 5. So, and don't forget to add an arbitrary constant. So in simplifying, we have now 1 over 3 of u raised to 6 over 6 plus c, and substituting the u by its original value. So we have now, it's be equal to 3 times 6 is 18. It's gonna be 1 over 18. Our u here is x cubed plus 3 raised to 6 plus an arbitrary constant. So that is our final answer. So next, if we're going to integrate a product function, for example, we have the integral of y e squared minus y squared 5 dy. So as you can see here, is this is our b and this is our a. B is the second function, a is the first function. So therefore, if b prime is equal to a, so therefore our u here, we can represent the b as our u. So we have here u is equal to b. So u is equal to, our b is equal to a squared minus y squared. And we find the derivatives of our u. So we have here du. And this is a constant, so therefore the derivatives of minus y squared is simply as negative 2y dy. And as you can see, the derivatives of u is equal to the first function, and we can easily cancel that out. So therefore, by finding the dy value, we have dy is equal to du over negative 2y. It's negative 2y. So therefore, by substituting our represent value to the original equation, we have the integral of y, and this thing is u, represent as u, and raised to the n power, which is 5, and our dy here is the value of du over negative 2y. And as you can see here, you can cancel out the y, and then what's remaining is we have a constant of negative 1/2 that we can isolate outside the integral sign. It's negative 1/2 integral of u raised to 5 du. And in this function, we can use the power formula of integration. So it's become negative 1/2 times u n plus 1, which our n is 5. So 5 plus 1 is 6 over n plus 1. So also it's become over 6. Then add c. So by simplifying, we have 1/6 times 1/2. It's equal to 1 over 12. Then by substituting our original value of our u, which is equal to e squared minus y squared raised to the power of 6 plus an arbitrary constant. That is our final answer. So next example we have, how about if we integrate v times v squared plus 3 raised to 3 dv. So as you can see here, if it is our if this is our a, if we get the derivatives of b, which is b prime, so we can say that this is equal to a. So therefore, we can represent our u here as our b. So therefore, our u is equal to b, which is equal to v squared plus 3. And finding the derivatives of u or v is equal to 2v dv. So by finding the value of dv is equal to du over 2v. So by substituting, we have it would be equal to the integral of v, and this thing here is equal to our u raised to the power of 3. Our dv here, the value of our dv here is du over 2v. So as you can see, we can easily cancel that the v, and what's remaining is we have a constant of 1/2 that we can isolate outside the integral sign. So we have 1/2 integral of u raised to 3 du, and we can use here the power formula of integration. So it's easy, become 1/2 times u. Our n here is equal to 3, so we have n plus 1 is equal to 3 plus 1, which is 4, over n plus 1, which is 3 plus 1 is also equal to 4 plus an arbitrary constant. So therefore, by simplifying, we have 1/2 times 1/4, so we have 1 over 8. Our value here of u is equal to v, original value is v squared plus 3, which is raised to the power of 4 plus c, and this is our final answer. And last example we have, how about we ask to find the integral of x minus 4 x raised to 8 raised to the power of 6. So what we're going to do here is to factor out the inside the function. So we have the integral of, we have x multiplied by 1 minus 4 x raised to 7, and these all are raised to 6 dx. So as you can see here, this kind of function, the power rule says that if u times m raised to, let's say it's a, it would be equal to u raised to a times m raised to a. So therefore, we can rewrite this function as, if this is our u and this is our m and this is our a, so it's become x raised to a, which is 6, times 1 minus 4 x raised to 7, also raised to 6 dx. So now, as you can see, we can easily use du and u representation to this kind of function. So therefore, if we represent this is our a and this is our b, so to find whether these two are we going to use as represent as u. So as you can see, if we differentiate the b, which is on higher power, which is 7, the answer would be equal to the a. So therefore, this b, this function, is what we're going to use as represent as u. So therefore, we represent u is equal to 1 minus 4x is to 7, and finding our du is equal to minus 28. 4 times 7 is 28, x raised to 6, and therefore is x raised to 6, which is equal to a, our first function, dx. So finding the value of dx, we have du over minus 28 x raised to 6. So therefore, by substituting our represent variable to the original equation, so we have integral of x raised to 6. This thing here is our u, which is raised to 6. Our dx is equal to du over minus 28 x raised to 6. So therefore, from this thing we can cancel the x raised to 6, and what remaining is a constant, which is negative 1 over 28, that we can isolate outside the integral. So it's become 1 over 28 times u raised to 6. By power formula of integration, we have n raised is equal to 6. So by adding 1 to the exponent, we have u raised to 7 over 7 plus an arbitrary constant. So therefore, in simplifying, 28 times 7 is equal to 196. 196. And by substituting the value of u, we have our u is 1 minus 4x raised to 7, and then raised to 7 plus an arbitrary constant. So that is our final answer. And that is for this video. Please subscribe for more videos.